So our next session is an introduction to guiding robot design for your teams. For this season, I would like to invite back Joe Varnell and introduce Michelle Newman and Jim Broadnick. Michelle has coached robots for 4 years at Mesquite ISD, including successful FLL and FTC teams. She also mentors mainly coaches and teams within the district, or many coaches and teams within the district, and hosts FLL Explore, Challenge, and FTC qualifiers. So Jim has been involved with FIRST since 2012 as a coach, tournament host, referee, and judge, as well as conducting seminars and trainings for fellow coaches. When not volunteering with FIRST, he works in integrated logistics support for a defense company. So I know you all have a presentation, so I'll let you all take it away.
Hi.
Hi, everyone. So we are going to share our screen, and I'm doing that now. And we're going to be looking at documentation off the bat, but the robot design involves programming and strategy as well as mechanical design. In this session, we're focusing on the mechanical design, but it's hard not to bring in the other aspects. And in reality, that's how you're going to be building and designing your robot, is in consideration of all aspects. So with that, I'd like to turn it over to Michelle to continue the emphasis on how important the documentation that is provided is going to be to a first-year team. Michelle?
As Kelly stated earlier, when you register a team and get your challenge, you will get 3 things. You'll get your team meeting guide, your engineering notebook, and your robot game rule book. These 3 are very important before you even start building or programming your robot. Your team meeting guide, this is a comprehensive guide that provides guidance and lesson plans on how to run your sessions. Your engineering notebook is a workbook that is used to record your ideas, notes, and sketches. And your robot game rulebook, which you need to refer to over and over again. Because I see teams coming to competitions and they forget the rules or they don't know the rules. And making sure that everyone knows the rules and understands the rules is very important with all the competitions.
Moving back to onto the next one, it's talking about the engineering design process. And we know that there's a lot of different versions of this out there, but we like to start with this very simple version, especially with the younger kids and especially with those teams that may not have been exposed to an engineering design process like this. But as your team advances, you can also move to the more advanced ones. This one simply starts with ask questions like, well, what's my robot supposed to do? Imagine is the second step. Let's imagine how we can resolve those problems that we just talked about in asking. Then we plan on how we're going to address those problems. Then we create a prototype and we create different models to see how those work. Then the last step in this round is to look at an improvement. How can we improve it? How can we make it better? Then the process starts over again. And you keep asking yourself, you imagine, you plan, and you create. And you continue to work this circle and refine it until you come up with a robot that best meets the needs and solves the missions that you're trying to do. We're going to continue on now with some different types of robots, some general high-level looks at them. And Michelle, would you like to talk about the educational robot a little bit?
The educational robot is an awesome robot. It's provided by the education Lego Education, and you can go online and find everything on how to build it, also buying the kit as they recommended before, especially for beginner teams. You can use this robot to compete with. It's simple and it's very useful. It does have all the parts and the purpose of a competition. It's a very useful robot, great robot to buy.
Okay, and before we move to the next sample, I would like to mention that these slides are available on roboplex.org. They have all the links active in it. And again, that is roboplex.org.
And also there are lessons and activities for beginner or beginning teams to use with the educational robot.
Thank you. Okay, so we talked about the engineering design process and how we work through and we look for ways to improve. This is a sample that they started with the engineering, the educational robot, and then made improvements on it. As you can see, they added a bumper in the rear. This is to align to the walls in the fields. They've added a frame around the robot to stiffen the axles that support the wheels. And they've added a attachment, a common attachment place in the front with a power takeoff, a PTO, that allows multiple attachments to interact with the robot without changing the motor or the cables out. So this is a very good example of how the engineering process was applied and the robot developed over time. Joe, would you like to talk a little bit about Spike Prime?
Sure. Spike Prime is just it's their new robot setup. It's uses all the same parts as EV3. Well, the sensors and the brick are different, but all the same interchangeable parts. In the with the Spike Prime, you get the building guide to build a basic robot, or if you got the expansion set, more extensive basic robot. This one is the more extensive one, has motors and gears to take off. The power takeoff has sensors and for line following, and that's some of the stuff you need to make sure you have everything kind of coordinated on your robot so that you can get everything on there. It's real nice.
Okay. Next, we're going to talk a little bit about the Rubik. That was mentioned in the project. Well, there's also a section on the rubric for the robot design, and it covers three main areas, and that is the mechanical design, the programming, and strategy and innovation. So each of those have a criteria set that you need to look at and match. And we're going to talk about some of these areas in the following discussion. But one point that I do want to bring out is the innovation portion of this. As a judge and a referee, I'm very excited when I see a team come up with a unique solution to a mission, to solve a mission. That's really fun. It's fun to watch them perform on the field with something that's new, that's not seen. We also want to mention that the Rubik can be used throughout the year to help your team evaluate. It was talked about in the project. But you can evaluate your robot along the ways too. It's like mechanical design. You ask questions such as, how sturdy is my robot? When I pick it up, does it flex? Does it bend? Does it fall apart? That leads into your mechanical design accomplishments. So with that, I'm going to turn it over to Joe to get us started on some of the basic design tips.
So on one of the main things is in my opinion, is keep it simple. I've seen so many large robots at championships just disintegrate. Simpler is better. You need to look at how the robot's going to move around the field. If all the obstacles are really close together, you need a smaller one, or one that goes over them all, but it depends on how tall the missions are. Wheel size, smaller is more accurate, larger is quicker. You need to find some kind of plus and minus on that. Attachments, you really need to get them on and off quick. If you have to, if all you're using is pegs for attachments, redesign. Come up with some way to slide your attachments on, or something like that. Or some robots have had them slide all over the complete robot. Make sure that your robot can use black line. Use everything for figuring out where it is. Designed to minimize time and base. That is probably the most important thing, which means quick on and off of attachments. Make sure
So
it's 30. Go ahead.
this is Jim. I'd like to jump in on that one. That is very interesting. They minimize time on base. When you think about it, you as a team have 2.5 minutes to score as many points as you can. I've actually timed teams at the competitions to see how much time they spend in base. And I have found that teams that typically don't do as well spend up to 1.5 minutes in base. That gives you 1 minute to score your points. The teams that are usually the top performers spend less than 30 seconds combined total in base. That gives them 2 minutes to score points on missions, to solve missions. It's really simple math. If I have 1 minute to solve missions, I'm not going to solve as many as I can in 2. And this is where a lot of first-year teams struggle, is the time spent in base, the time. I like to think of it as a NASCAR pit. If you watch NASCAR, they practice. They script every piece of their movements to get that time down. That can be done in FLL robotics too. You practice as was mentioned. You practice as you compete. Okay, and if you never practice changing attachments out between or timed runs, when it gets to the tournament, your team's going to struggle in those areas. We talked about simpler is better as well. Simpler robots have a tendency not to break quite as much. If there's not as many moving parts and not as many items on that, they just don't break as often.
And I agree with you on that, having attachments or main attachments where you can have multiple attachments to take on and off to that main attachments. I've noticed that a lot of teams that do well, they have main large attachments that are probably powered, but also have to where you can add passive or non-powered attachments where you can add on to them and take them off very easily and quickly during the competition. They do well, they do better.
Also, when you're designing a robot, you have to remember that it's, this isn't a technical term, but it's going to be kind of janky. It's going to be kind of loose. It's not going to be accurate. And so you need to make sure you design something to help you be accurate. If you, one team, Republic of Pi, they said after 2 turns, they know they're going to be off. And so they need to go against the wall or find a black line and get squared up again. So, because your robot is always kind of loose, it's even if you make it structurally sturdy, it's still not going to be quite accurate. So, make sure you design for realignment.
Okay, so one of the things I like to say about Legos is one of the greatest things about them is they come apart. One of the worst things about them is they come apart. And they always seem to come apart at the worst time. So as Joe was mentioned, you need to make structurally strong, but there's still going to be some flex in there and some chance to introduce error into the robot navigation and positioning.
I think something that's very important, and I would like for you to elaborate on for competitions. It says design robot to always start from the same location. That is very important.
Okay, I'll go Joe, if you don't mind. This goes back to the practice, in my opinion. When you're up there, you're under pressure, you're under, there's a lot of excitement and tension going on, and you're trying to remember, okay, do I position my robot in this position or that position, or should I start on the south wall? Do I start on the west wall? Do I line up on this grid? Just remove that all. If I started in the same place for every mission, I don't have to worry about where I align it. Then you use the programming to adjust the robot to get to where it needs to be. This is what we were saying in the beginning, that your design, your robot design really encompasses programming and strategy. What's my strategy to get there? Uh, so, Joe, any?
You did well.
Okay. So there are some teams that like to use jigs. I have found some teams use them very effectively. And a jig is a lining mechanism built out of Legos. Remember, everything you bring to the table has to be Lego. Okay, and there are certain rules of what can extend into home or what can't extend into home last year. Don't know if those are going to continue this year, but you will need to look at those. But you are allowed to use a Lego jig, something made out of Legos, to help you align it. Usually they align in the corner or against the edge of the mat and in a position against the robot somehow. The only thing you got to worry about jigs is as the robot leaves, is it drag on the jig or throw it off? So that is one method of alignment. The other method is using the grid. If you look into the launch area, as it was termed last year, they print a grid system on there for you that you can use to align the robot with. The great thing about the grid is it's the same on every mat. Your tables will vary some from competition to competition. The wall height may vary a little bit, but that mat is a printed mat. That grid is always the same from whatever line you choose on there to wherever the mission is printed, to where the mission aligns. That distance is always the same.
One warning about
Sorry,
what?
Joe.
Sorry. One warning about the grid is there's lots of lines, and so make sure you get the right line if you use the grid to line up. Because if you're using the 6th line, it really looks like the 5th and the 7th line too. So, sorry, Michelle.
Sure. Well, I also learned about the jig with our team is that tables, just about any table you can go to any competition, tables can be off by centimeters, and it can change your whole start off. So what we have learned to do is we take our jig and put it on the competition table just to see how aligned it is before we even begin. So do test out your jig.
Yes. So, Joe, I'd like to go back to wheels a little bit. You mentioned some of that. Bigger wheels are typically faster, and that's because the circumference is larger.
Correct.
One rotation, it covers more distance. And that is something that we like to teach the students is how to, use the circumference over the wheel to calculate how far the robot's going to move. We teach them circumferences in math class. But now we give them an example of how they can apply it. So one rotation, we know if the circumference of the wheel is 17.52, which happens to be the EV3 wheel, they rotate. If it rotates once, that robot's going to travel 17.5 centimeters roughly. So how many, yes, thanks, Joe. How many rotations can it take to navigate across the field? The issue with bigger wheels, and while they travel faster and being a little accurate, is every wheel's 360 degrees around. So a larger wheel, 1 degree covers a little further in measurements. So when you rotate and try to get precise, if a larger wheel, if 1 degree is a tenth of a millimeter, a smaller wheel may be half of a millimeter. So you can fine tune that a little bit. So that's kind of the difference I see between small and wheels, and finding a balance is critical. Also, we were talking a little bit about the flex in wheels. Wheels have a tendency to the rubber wheels have a tendency to shift and flex a little bit, which tends to throw them off. I'm interested in trying the spike and seeing how they work. I know that they are available in other kits and available online. I haven't had much experience with them. The other thing I found with the standard wheels in EV3 is if you let the robot sit on them, let the weight of the brick sit on your robot, they develop a flat spot, which tends to throw the robot off as it rotates. So I like to have the students either store the robots upside down or build a little support out of Legos that the robot can rest on to keep the wheels off of the ground. Any input on the wheels or additional? Okay.
I think the
So,
smaller wheels make better turns, more accurate turns.
okay.
What is your take on passive versus powered attachments?
Okay.
All right, Jim.
Okay. As a judge, I like to see both. I like to see your passive attachments, those that aren't driven by a motor. I like to see the innovation that the students come up with. Gravity's free. It works consistently pretty much every time. Motors, you have to use a port. You have to have programming. There's some error in that, but it's not that they're bad or good. I like to see a combination of both that best solves the mission. And I think that's really what we're looking for, is if it can be done with a passive attachment that has no moving parts, typically that's not going to break. You know, we talked about the ports on the EV3, and I've seen it numerous times on my own teams as well as teams in competition. Something happened, they unplugged a motor, it gets in the middle of the robot run, and that attachment doesn't turn or doesn't rotate because the plug's slightly unplugged, or they got it into the wrong port. And with passive attachment, even whether gravity fed or use of the rubber bands, typically that doesn't happen. Yes, I've had rubber bands, the rubber bands break. So.
As far as passive versus motorized attachments, whenever I've worked with teams, I suggest them going with a passive attachment first. But if they can't figure it out, there's nothing wrong with going motorized.
Mm-hmm.
The main thing is to have it be consistent. If it's a passive attachment, but it only gets it 2 out of 5 times, but a motorized attachment will get it 5 out of 5, a mission 5 out of 5 times, go motorized. But you do need to worry about all the different, don't go complete, in my opinion, don't go completely motorized, because you'll run out of motors. And
Yes.
Board. Okay. So one of the things that common mistakes I see on especially first year teams is they build these great, fantastic robots, but forget that batteries do die and you can't get to the charging ports on them without disassembling the robot. Or if you're still using, your A cells, your batteries, your dry cells, that means you have to take the brick off to do that. Every time you disassemble a robot is a chance to get it back wrong or differently than you have originally, which means it could affect your robot performance.
I have noticed with a lot of new teams, they do build and block their ports, and that needs to be open as well.
Right. So make sure you have access to the ports and the battery charge. Battery performance. These are a rechargeable battery. As the voltage drops in them, the performance changes. And I have a lot of students will come to me and say, it's completely changed. My robot's not working anymore. What have I done? And usually the first question I ask them is, where's your battery level at? We found if it drops much below 7 volts, roughly, it really starts to affect the performance of the robot. And almost every time the student comes back to me and says, oh, my battery's almost drained. Okay, let's charge it up before you start rebuilding, because their first instinct is, let's tear it apart and rebuild. So.
well, along the lines of covering ports, you also need to build to where you can see your screen. Typically, a lot of teams use the screen for information. And also, make sure every part on your robot serves a purpose. if you have a robot that you build, I've worked with several teams. They built robots that were really cool looking, but they didn't score, and things would fall off just randomly and get in their way. Just make sure every part has its purpose. Make sure you can see the screen.
Yes. Let's move on to the next slide. And Michelle, this is some basic troubleshooting. We've talked some about it, but would you like to talk a little bit about it?
Yeah, troubleshooting, which is very important and very helpful. It helps you learn a lot about your robot. And some of the things that we, for basic troubleshooting, is identify and verify the problem. The next one is rule out the obvious. Start with simple solutions, use isolation, troubleshooting techniques. And then also, none of us as smart as we all think we are, or anyone else. But identify the problem, try to figure out what the problem is, what's really going on, what's wrong. The next thing is rule out the obvious. Is your cables plugged in? Are you running the right program? And those are some of the simple things you can see or your teams can do to figure out if that is the problem with the robot, why it's not functioning correctly. The next thing you can do is start with a simple solution. And by doing that, you can check the battery, replace parts that you know that are good or bad or you've been using for a long time. You can also isolate troubleshooting techniques. And then after you've done all these things, you can go online and look for solutions, Google problems, and sometimes you'll see results come up from where others have had the same problem. And also you can go to roboplex.org, and sometimes they add in or upload information about similar problems that other people have.
The Google groups too.
Yes, Google group. Was that North Texas FLL.org, I think. I think it's in the chat. Kelly,
Yes.
what's that?
Yeah,
What's that group?
I always just Google North Texas FLL Google group and it pops
Yes.
up for me.
Yes.
So yeah, even if you're not in North Texas, you're more than welcome to join and check with your partner to see if there's something like that in your regional area, because there's so many great resources out there and so many people are so passionate.
Yeah, and you get responses very quickly, very quickly.
Definitely.
All right.
Especially in North Texas.
Yes.
I was going to post something and it was already posted. So I'm like, yes, I appreciate you all.
So one of the things I do like is the takeaway on the bottom of that is you can observe a lot just by watching. And Yogi Bear always had some funny statements and way of putting things, but that's so true, is just to get the teams to watch the robot and what it's doing. And sometimes that involves in breaking the program down into pieces. And I think the key is, as Michelle pointed out at the end, is none of us are as smart as all of us. Reach out for help. Don't be afraid to reach out for help. I know we're getting close on time. Do we want to take any questions, Kelly?
Yeah, because we can go all day about troubleshooting.
Yeah, we have a couple more minutes, but is there, I guess my big question is there ever a point in the season that you all think that a team should stop redesigning their robot? Like,
Yes. Yeah, give the programmers a couple of weeks.
Yes.
And stop your design a couple of weeks. You might have to make adjustments at the last minute, but work with your programmers, because I've seen so many teams like rebuild the robot the night before, and then they get mad at the programmer because all of a sudden it won't move right.
Mm-hmm.
So please stop a couple of weeks early so that you can let the programmers have some time to really tune out the programs.
Yes, and during that time, while they're programming the robot, then you can go and work on the CAD. But yes, you definitely got to give your programmers at least 2 or 3 weeks.
Right. Yeah. When we approach a tournament, we lock the robot down, and it requires what we term an engineering change request. You have to make a case for why you want to change a mechanical portion of the robot, and that has to be approved by the team as a whole.
Exactly.
Nice.
That way you just don't have the builders going off the night before the tournament and changing that. Mm-hmm. And real quick, I'd like to jump back to the slides because Michelle brought it up, and CAD for Legos, and thinking about how we're going to build in this COVID-19 era. And that's going to be very tough. Not quite sure how it's going to work out. One of the things we're considering is using some of the free Lego CAD tools out there to let teams come up with different ideas and share them online. There's 2 listed there. There's others. I like to use the Lego Digital Designer with the younger kids. I think it's easier to use personally, but both of them are great. Both of them have just tons of bricks. And this may be a resource that you can have online virtual design interchange.
Definitely.
I think we're done.
Yeah, that's going to be a really good resource. Yeah. So thank you for mentioning that. Yeah, because it's going to take some thinking. So hopefully we can mention more about that, talk more about that in our next session, our next virtual conference. Because I think a lot of coaches would be very interested in that. I know I'm interested in learning more. So thank you all so much for joining us today and for telling us all about this introduction to robot design. It was really great to hear from you all and learn from your vast knowledge. So thank you all.